design brief for Recur was making an incredibly efficient, affordable chair. How can we make it a really high performance ergonomic task chair? And how can we weave in circularity? Thinking about how big a sustainable impact this chair has over previous chairs that we've done. The Recur chair is a culmination of a huge amount of research, both ergonomics, sustainability research into materials, how we can make the most efficient, affordable, sustainable chair we possibly can. The way in which we've been able to make the chair incredibly affordable is all about efficiencies. Efficiency in the material that we've used and how much material's gone into the product. Efficiency in terms of where the components are sourced from, so proximity to our factory and our assembly plants. Efficiencies in the speed of manufacture, so the sewing time, the assembly time. The size of the machine that the injection mold tools go into, all of that has contributed to making each and every single component really stripped back and super effective, super efficient. Each and every component has been designed in-house, and that makes for a more harmonious chair. You don't necessarily always get from so-called kit chairs, which are sourced from various different component manufacturers. We have complete design autonomy when everything is done in-house, which is a real big benefit when designing anything. And I think Recur is a really good exemplar of that.
We had the visual of what he was after. We take the design from Phil and we design the parts for manufacture, but we also have to consider what the parts need to do. So testing purposes, the strength the part needs to have, kind of how parts interact with each other is a part by part level, and considering it in the product is the main role that we have as engineers, that we're not just looking at one product, we're looking at a whole suite of 26 parts that are working together to give us the Recur chair. From an engineering point of view and a manufacturing point of view, we looked at every part of the chair and whether we thought it needed a mechanical fixing or whether it could go for a clipping method. So on Recur, we've got 6 fixtures and fittings altogether, 6 bolts. The first 2 are on the arm. So with the arm, we've got a slot here, and that arm slots into the seat pan of the chair. It holds itself. We don't need to use the bolt to hold it in place, but we then have a bolt going up through the bottom, straight into the seat pan. If you ever look at the bottom of a Recur chair, you'll see that fixing, and we're quite proud that you can see the fixing because we're showing it's the honest construction of the chair, that that bolt is holding that arm onto that chair. If anybody ever needs to replace an arm in future, all you have to do is replace that bolt, replace the arm, new one on, and the new bolt. What it also means is that chairs can be upgraded or changed if they ever need to be. If usage changes, if you need to take an arm off of a chair, you just unmove the bolt and it comes off. If you need to add an arm to a chair, then we can supply arms, they slot on, and a bolt goes back on.
The back frame is a really interesting component because after the mechanism, it's probably the second heaviest component. It's the largest component on the chair, so it's an area that we can make some really great gains in terms of material weight and efficiencies. Obviously, by designing a component using the least amount of material possible, not only makes it cost effective, but it also had the happy byproduct of making an incredibly flexible and dynamic component. So when a user sits in the chair and reclines in the chair, the back has this lovely torsional flexibility to it, which was a really nice byproduct of trying to come up with a way of designing a component that didn't weigh too much.
One thing which in recent years has gone really well with our task chairs is using a shrinks mesh, which once heat is applied, the mesh will shrink to a certain profile. We've got a very skilled team of development technicians and engineers that specialize in different fabrics and materials. So they came up with a pattern that we can effectively have mesh cut in our sewing department, a gasket sewed around the outside, That gasket then slots into the back frame and we put that into an industrial oven, and the mesh will then shrink to the profile that we need to give the most comfort we can for the chair.
The Recur chair has been 3 years in the making. It's based on an awful lot of research and concept design. Everything we do is rooted in sustainability and ergonomics. They are the cornerstones of what we do here at Orangebox. It's delivering great ergonomics at an affordable price point. One thing that Orangebox has always been very, very good at is bringing value from higher priced products down to a more affordable category. And I think Recur is a really great example of that. The name itself has its foundations in sustainability, so the meaning of Recur is to occur regularly or periodically, and that's exactly what we want this chair to do. Through its design, the chair itself and the materials from which it's made stay in constant cycles, constant loops in line with the circular economy. So yes, many of these materials have had one previous life already, in which we've designed these parts to be easily disassembled at end of life, mean that they could go on to have a future life as well.